बढ़िया. Quickly say hi to your class teachers. We have 3 class teachers: Deep sir, Sachin sir, and Anshul sir. Quickly say hello to your class teachers, everybody. Everyone. Well done. Okay, guys. So this is our fourth and last session of momentum and collision. Okay, we have spoken about cases of collision in the previous classes as well. Okay, good, awesome, fine. So shall we start? Write +1 in the chat box if you are ready. If you are ready for the session, just write +1 in the chat box. Great, awesome. चलो भाई start करते हैं. ठीक है. Yes, चलो switching off the chat as always, you know that. Switching off the chat so that now you guys focus on the screen. Okay, class teachers. I will tell you when can you forward the doubts to me. We have very little theory to cover today. Okay, guys, and keep your doubts noted. If you want them to be only asked to me, okay, I will give you guys a time to ask them. In between, do not ask the doubt because it disrupts the flow of the class only. If there is a general, normal, simple doubt, okay, which you think you can answer, ask your class teachers as well, you can ask them. But if there is a specific thing that you want to ask me, especially if it is non-academic, not related to this topic, please ask me at the end of the class. Okay, guys, perfect. Chalo, let's have a recap of previous session. We spoke about the most important part of this entire series of sessions called as collision. We understood that collision is basically a process of transfer of momentum and energy. So when two objects are going to collide, there will be transfer of momentum and transfer of energy from one body to another. Okay. Also, during collision, there is one thing which you will always remember, that whatever be the type of collision, be it elastic collision, partially elastic collision, or inelastic collision, you will make sure that momentum is always written to be conserved. Yes, we are studying it because momentum remains conserved. So this is from JEE point of view that you will always remember. Then we spoke about the different types of collisions called as elastic, inelastic, and partially elastic collision. The entire game is of this value E. E is coefficient of restitution. In the next slide, I'll show you that also. Point is, in the case of elastic collision, the value of E remains 1, which suggests that the bodies after collide during collision, when they deform, they will regain their shape 100%. So there will be momentum conserved, there will be kinetic energy conserved, the body will also regain their shape completely. On the other hand, when we speak about perfectly inelastic collision, then the two bodies when they are colliding, the collision is such that there will be maximum loss of kinetic energy, momentum will still remain conserved, but more importantly, the two bodies stick to each other. That is the most important part about the inelastic collision, or you can say the perfectly inelastic collision. There, the two bodies when they collide, they will move together as a single body. And then there are partially elastic collision where value of E is somewhere between 0 and 1. The bodies do not stick to each other after collision, but they actually lose some amount of their kinetic energy in the form of deformation. And in deformation, actually, what's the kind of energy which bodies store is basically your kind of some potential energy that we will study in a chapter called as elasticity. So wait and watch, we'll speak about that also. And last time we only spoke about the head-on collisions, which are 1D collisions. Today we'll be speaking about the oblique collisions also, or you can say 2D collisions. Okay, and if you guys remember, I told you guys very important formulas, the derivation and their results. Final results are very important. The final velocities of two bodies when they are colliding head-on, and that too under elastic collision. The final velocities of the two bodies came out to be m1 minus m2 upon m1 plus m2 into u1, and 2m2 upon m1 plus m2 u2. On the other hand, when we spoke about v2 is m2 minus m1 upon m1 plus m2 u2, and 2m1 upon m1 plus m2 u1. Okay, and what is E? Coefficient of restitution, which tells you what type of collision it is going to be. The value of E is found as the ratio of velocity of separation to the velocity of approach. And when two bodies are coming closer, they come relatively closer with the speed of u1 minus u2. That's why it is called velocity of approach. Approach means the two bodies coming closer. They are approaching each other. On the other hand, velocity of separation tells you how fast the bodies are going to go away from each other after the collision is completed. Okay, so this is the entire story of the discussion of the last session. Let's see one important example based upon partially elastic collision. Okay, I told you guys there is formula where there was a type of formulas where E was also involved for partially elastic collision, but I told you don't need to memorize those formulas. Okay, so let's talk about an example based upon that partially elastic collision. Okay, so question says that if there is a body which falls normally on a surface from height h, what will be the height that the body is going to regain after the collision if the coefficient of restitution is E? Means what? Let me explain the question also once again. So it says that, say you have this surface, and this is basically ground which is not going to move. Okay, this is a very big object which is basically part of Earth, which we are calling as the ground. You can also call it a table, by the way, but immovable. Okay, and you have a ball which is going to drop from a height h. It is going to fall. Okay, after collision it is going to rise again up. I'm drawing it separately here, guys. So it will not definitely rise to the same level. We all know that, right? Why? Because during collision it is going to lose some energy. So what is the height to which the body is going to rise here? Can I apply law of conservation of mechanical energy? No. Why? Because during collision the system has lost mechanical energy, right? Kinetic plus potential energy is not going to be constant, because during that collision the body has lost the mechanical energy, maybe in the form of heat, in the form of sound, maybe in some other form, maybe deformation as well. So the point is, guys, when you approach this question, be very careful and listen to me very carefully when we are solving this. So what happens, guys, when this body is going to fall, this body could be any body, could be round body, could be spherical body, could be a stone also. When it travels for a height h and when it is just about to hit the ground, that time its velocity when it is about to hit the ground is going to be v, which we will find out. Okay, now when it collides, after that when it starts going up, at that point of time its velocity is definitely not going to be equal to v. It's going to be some other value, say v dash, and that is where we can say that now, because it is not rising with the same speed as it hits the ground, that is why it is not going to rise to the same height. And by common sense only you can figure out that speed with which the body is going to hit the ground is going to be more. It's going to be lost some amount, and that's why when it starts rising up again, the speed is going to be lesser. Okay, guys, the important part that I want you people to remember about this part is that the body which is moving, say it has mass m, and the body which is not moving has mass capital M. Maybe the table, I'm not saying it's ground, say it is a table on which the ball is falling continuously. Ball falls on the table, hits, comes up, again hits, comes up, again hits, comes up. It goes down, it comes up. But every time when it comes up, it is going to lose some kinetic energy. It's going to lose some mechanical energy. That's why every collision, the body's height to which it is going to rise, it's going to definitely reduce. So the point is, guys, if we speak about body number 1, okay, body number 1 is basically your ball, okay, the one which is falling, and body number 2 is basically the table. Okay, the surface of the table or the table itself. I'm not calling it ground because then you might start thinking it like Earth. I want you to actually focus only on the body number 1 only. Why? Because body number 2 is immovable. It's not going to move. Okay, that means what, guys? When we talk about the initial velocity u1, that will be spoken about just before collision. Why just before collision? Because the body is continuously accelerating when it is falling. So collision is going to happen when the ball is going to hit the ground or hit the table. So just before that collision, what is the velocity is what we call as the velocity before collision. Okay. Previously in the previous class, all the questions that we solved, the body was not accelerating. Now the ball which is falling, its speed is continuously increasing. So when it is going to hit the ground, that is the velocity with which it hits the ground or the table. Sorry, I'm calling it again and again ground, but it's table that I want to talk about. Okay. U2, the speed of the table just before the ball collides with it, 0. Okay. We will still be looking for this value, which is we are calling as v. U1 is basically v, the speed just before collision of what? Of the ball. What is u2? It is speed of the table just before collision, which is basically 0, right guys? Similarly, v1 is just after collision. Obviously, we are speaking about the ball here, just after collision. And that is the velocity that we have defined as v dash. And what is v2? Just after collision, table is not moving, so its final velocity still remains 0. Specifically, in examples, in questions and examples where an object is going to hit the ground, hit the table, where the surface on which the ball or the stone is going to hit, it's not going to move. You will always remember that v2 and u2 will remain 0. Okay, guys. Now, after traveling for height h, how much velocity the ball would gain? You can find that out by using second or third equation of motion or by law of conservation of energy also. Because between point number 1 to point number 2, the body's kinetic energy and potential energy, the sum of that will remain constant. But I will still write this by using the third equation of motion. That means what? V square is equal to u square plus 2 into minus g. And by what height the body has gone down? It is h. But because it is moving in the negative direction, I hope you still remember kinematics. Downward direction is taken negative. What was the initial velocity with which your ball started moving? 0. So what is the value of v that I get? Under root of 2gh. This is the speed with which ball hits the ground. Okay, that is v. Okay, people, that is v. Okay, and just after the collision is completed, it's going to rise with the velocity v dash now. So when something is going to rise with that speed, finally when the ball will again reach a height h dash, its velocity will again become 0. That means now if I speak about the final velocity, which is 0, will be equal to v dash square plus 2 into minus g, and this time it rises to a height in the positive direction h dash. That means if I call this point A, this point as B, and this point as C to which it is going, this is A to B ka journey, and this is B to C wala journey, everyone. So B to C again at C the velocity became 0. So from here, when you will find out v dash, on the right hand side it is v dash square, which is 2gh. So v dash comes out to be under root of 2gh dash. Means what, guys? We have got the velocity with which the ball hits the ground, the velocity with which it leaves the ground after the collision is completed. Okay, everyone. Now, if we speak about the situation where we have to talk about the velocity of separation, velocity of approach, because we want to write in terms of E. Okay, so let me take it to the next slide. Okay, so we have got v, which is equal to under root 2gh, and we have got v dash, which is equal to v1, which is equal to 2gh dash. This is equal to u1. So when we write E, we write it as v2 minus v1 upon u1 minus u2. Okay, everyone. And here, if we speak, say, numerically, or let's not even go numerically, this will in which we sort out. So v2 and u2, look at this. What is the value of u2? What is the value of v2? Both are 0. Okay, so we have v2, which is 0, minus v1. u1 we will already know, and u2 is equal to also 0, because 1 is representing ball, 2 is representing the table. So what do we have is minus v1 upon u1. Okay, guys. Now, once again, just have a look at the diagram for one last time. You know that this direction is negative and this direction is positive. That means when the body is about to hit the ground, the ball, it has negative velocity, and when it starts rising up, it has positive velocity. So that's why when I'm going to put the values here, I will put v1 when it is going up and u1 when it is coming down. So I will accordingly put the values. So v1 is positive. How much is v1? 2gh dash in under root, and this is going to be minus of 2gh in under root. This is equal to E. Minus taken care of. Squaring both the sides give me E square equal to 2gh dash upon 2gh. 2g and 2g gets cancelled. H dash comes out to be E square h. That means what, guys? If I know the value of E already, which is dependent upon the material of the body, if the body is, say, dropped from a height of 1 meter or say 10 meters, after first collision, the height to which the body will rise will be equal to E square into 10. Okay. Now from E square equal to 10, or let's just for a moment, this is the answer. Let's for a moment talk about a situation where we say that, say, E ka value is equal to half. Okay. And H ka initial value is, say, 100 meters. So H1, when the body falls and after first collision it rises, it will rise to E square H, which is equal to 1 by 2 ka square into 100. That comes out to be 1 by 4 into 100 or 100 by 4, which is 25 meters. Doesn't matter. Numerical value is not important. What I'm trying to tell you, again, when the body will fall, collides and rise up, this time it will have the next height as E square H1. Because now for the second situation, okay, now for the second situation when the body fell, first collision happened, it rose to a height that is H1. Second time when the body fell, second collision happened, it will rise to a height that is H2. So H2 will be dependent on H1. Again, from H2 when the body will fall, and third time when it will collide, it will rise to some height H3. Okay, so what will I write H3 as? I will write it as E square into H2. My objective is not to tell you what the numerical value is going to be. My objective is to tell you that if I put the value of H2 here, what do you see I get? I get it as E square into E square H1. And what is H1? H1 in terms of the original height from which the body was dropped. So it is E square into E square, that is E to the power 4 H1. And I'm going to put the value of H1 here. Okay, so see that. This H1 I'm going to put here. I get E to the power 4 and E square H. It comes out to be E to the power 6H. So after third collision, this is after third collision, this is what I get. I'm going to generalize the formula and write Hn as, or I change the color, write it as with the red color. Hn is going to be E square to the power n times H. Let's apply this. If I talk about only one collision, n ka value will be 1 and H1 will be E square H. Yes, it is E square H. If I put second collision, after second collision, how much the height is going to be? I will put n equal to 2. So it will become E to the power 4H, and that is E to the power 4. Sorry, second one. This is going to be E square. Okay, if I put here E square into E square H, so this comes out to be E to the power 4H, and that's what we get. If I talk about third collision, E to the power 6H, E to the power 8H, like that. So this is the generalized formula for nth collision. Okay, guys, are we clear? This is a specific type of question that you will find in maybe Tattva as well, and in many other texts you will find this kind of question. This definitely has come in JEE examination, but I want you people to remember the approach, and if you remember directly the formula also, that is absolutely fine. If you remember this happens. Okay, awesome. If you can, that's good. If you can't, then at least remember the approach, that it is about the velocity finally and velocity just before collision. You can always find that out. Okay. Important thing to understand in this question is that velocity of approach is dependent only on the ball. Velocity of separation is only dependent on the ball. Velocity of approach and separation is dependent only on the ball because ground is not moving only. Getting? Yes. So speed with which it collides Just before collision, the speed is velocity of approach, and just after collision, the speed is velocity of separation. Okay, well done. Okay, guys. Now I'm going to give you an unrelated question as a quiz, and I will give you a hint also. This is really a good question that is coming. So does it mean that G do not have any role in this? Definitely G has a role, but the point is, Samarpita, if you remember, when we speak, see, there is a question that has been asked. I'll answer this question. Yes. So everybody, Samarpita has asked that, sir, does it mean that G does not have any role to play? Definitely G has a role to play in the entire mechanics of the situation. But the point is, if you people remember collision, during collision there should not be any external force affecting the motion. On the other hand, when we speak about this case, okay, ball plus this ball plus table or ball plus ground, if you're talking about these two bodies. If I consider table, then definitely the situation looks complicated. That table has an external force, table and ball both have an external force, which is the gravity coming from the earth. So that is why when we apply the velocity of separation upon velocity of approach expression, this velocity of separation upon velocity of approach, E curve expression, we apply this, and this is only thought of for the time duration when the bodies are colliding. So just before collision, the velocity of approach; just after collision, the velocity of separation. Why? Because if the bodies are accelerating, then in that case, the velocities V1, V2, U1, U2 might also be changing, which is happening in this case. U1 is continuously changing, V1 is continuously changing as the body goes up, it decreases. So for the time when the bodies are under impact, only for that duration you talk about this. And in that case, we say that it is not gravity which is the impulsive effect. It is not gravity which is creating the impulsive effect. It is the colliding force, the normal force acting between the two bodies which are colliding. Because of that, the momentum transfer is happening, and that is not gravity. Gravity is only bringing them closer. But the impact during this time, the direction of the body is changing because of the normal force which is acting between them. Okay, cool. Means you can think of it this way: that if this ball falls on a sponge floor, a floor which is perfectly smooth, perfectly like a sand or like spongy floor, very cushiony floor. So when the ball will fall on that, also gravity is bringing the body down. But in that case, the body may not even rise up. Why? Because the impact force has become very weak. So in that case, maybe the ball may not rise up and the value of E becomes zero because velocity of separation becomes zero. So that is why gravity has a play in the entire situation, in the mechanics of it definitely, but it does not have an impact. It is not an impulsive force. That is why it does not have an impact in the collision case. So that is why we are speaking for the time duration, which is very small, and during that only we are defining the value of E. Okay. Now, as I said, we'll move on to a question which is from Parshma, perfectly inelastic collision. Okay, I'll guide you about the question. It involves the concepts of work power energy. It involves the concept of collision also. So let's go through the question. I'll give you time. Do not try to rush in this problem. I want you to take the complete time that I'm going to give you. Don't try to rush to this question. Okay. So have a look at the question, guys. It says that we have a pendulum kind of situation. Forget about what pendulum is. It's basically a thread and a bob which is hanging. Bob is basically a box. Okay, so wooden bob is basically a wooden block which is hanging. Its mass is given as 1 kg. Okay, and it is hanging stationary. So a bullet whose mass is 0.01 kgs. Okay, or 10 grams is the mass of that bullet. It is moving with a speed of 200 meters per second. It collides with the wooden block, gets embedded with the bob. Gets embedded means what? It penetrates through the wooden block, stops inside. Or when I say stops inside, it stays inside. But now the block plus bullet system starts rising up. When it rises up, it rises as a vertical circular motion. Okay, but we don't have to worry about the vertical circular motion part in this question. You have to find out the height to which the bob and the bullet system will rise. This height is what you have to find out. Okay, that's why you see total mass m is there. I've given you the hints also. First, you will try to understand that this is perfectly inelastic collision where two bodies become one and move together. Capital M plus M mass. Okay, so collision is there. So momentum will be conserved. Second one, you will try to find out the value of the velocities of the two when they just start to move. Means this process of collision, you know that lasts only for a fraction of seconds. So just when the collision is completed, they start rising up. So with what velocity do they start to rise up? Okay, here obviously the final velocity will become zero. You are interested in talking about the velocity of the combined mass just after the collision. You want to find that velocity. Okay, and then apply law of conservation of energy between point A and B. You will get the value of H. Okay, guys. I'm not helping you guys out with anything other than that. I think I've spoken a lot already. Now I'll give you guys 2 minutes. Take your time. Don't rush. Your time starts in 3, 2, and 1. Seconds remaining. 1 minute is gone. Last 25 seconds. Okay. Okay, well done. So first of all, everyone, realizing that it is perfectly inelastic collision, you know that the momentum will remain conserved. So at position A, the bullet will penetrate, and they will move together. So just at A only, the mass which is moving is the bullet moving with a velocity u. Wooden block not moving at all. So I'm writing momentum conservation. The combined mass m plus m will start rising with the velocity v. Okay, so this part is 0. The velocity with which they start rising is mu upon m plus m. So we'll simplify that part. I'll show you the maths separately. The point is, this is the first part of the question. Now you have to just look at it as a vertical circular motion or vertical situation where at A, if I define this as h equal to 0, the system has only kinetic energy and no potential energy at all. So between A and D, energy at A should be equal to energy at B. Energy at A is half m plus small m into v square. This is the speed, or this is the kinetic energy with which your combined mass starts to rise, and m plus m into g h to which it is going to rise, and kinetic energy will become 0. Initially the potential energy is 0. Okay, yeah, m plus m becomes 0. From here the h value comes out to be v square by 2g. So if you get the value of v, your problem is already solved. I hope the steps are clear to all of you. Now let me show you the mathematics also behind this. Okay, so we found the value of velocity. By putting up the value also, you will get this value as 2 upon 1.01, which is very close to 2 meters per second. Okay, very close to that value we get. You can take it as 2 only. And then when we simplify this part, v square by 2g, so you can say that this is 2 by 10, so 0.2 gas pass means I will not even go by this approach like this. I will say that it is nearly equal to 2 meters per second, the velocity with which the combined mass starts to rise, and h is going to be v square by 2g. V is equal to 2 square of that, and 2 into 10. I'll not even take g value as 9.8. I've told you guys that in J examination. So this is 2 by 10. Okay, so h comes out to be 0.2 meters. Okay, hello, yes Animesh, tell me. And what is that concept? You're suggesting you must be aware about the concept also, right? So what is the concept? How will you approach this in that ballistic pendulum concept? What is that? It's not approximately. This is what we call as. Okay, this is what it is. No, I thought maybe you have some other impression or some other approach of it. So I wanted to be sure. This is what it is. This is what it is. Okay. Okay. Cool. Is everyone clear with the approach? Let me show you the approach phase first. Everybody. Any doubts so far? See, as I told you guys, from this chapter onwards, now you can expect questions from multiple concepts, and precisely this is what is happening. Many times Jay has asked questions which are precisely the situation in front of you. This situation sometimes is being asked as the bullet penetrates, comes out of the wooden block, and then the wooden block goes to rise. So that way also the question is solved. But in that case, they tell you the velocity with which the body comes up. Okay. So how kinetic energy in position A is equal to kinetic energy in position B. When did I say that? It is total energy at A equal to total energy at B. Does it look like expression of potential kinetic energy to you? The right side of the equation, does it look like kinetic energy? It does not. Okay. It is mechanical energy. So friction there is so friction there in that case, sir. Probably. Yes, Larry. Probably. Okay. Okay. Daksh is helping everyone out. He is sharing something from his experience. Please do not share emojis because it might freeze the chat for you. Okay. Sir, first part not understood. Let's speak to Aryan. Yes, Aryan. Which part are you? Yes, which part? Yeah. So basically, when the bullet hits this body, the collision happens, right? And in collision, we say that initial momentum should be equal to final momentum. You were there in the previous class or not? Right. So initially, bullet is moving, block is not moving. So bullet has momentum, block has no momentum. Okay. After that, both of them together have the momentum m plus m into b. Okay. Okay. Sir, how mechanical energy conserved? Purushottam Kumar. How mechanical energy conserved as in when a body is going to rise up. In this case, when the two starts to rise up together. If I speak about this situation, okay, say after collision is completed, once the collision is done, that is when they will start to rise up. There is a bullet inside. They start to rise up with a velocity v, and finally their velocity becomes 0. In this situation, we are assuming that air force or air resistance is 0. So there is no non-conservative force present. And when there is no non-conservative force present, can I say that the mechanical energy of the system must remain conserved? Right? Sure, Vishesh. Absolutely. Anything for you, bacha. Am I audible, everyone? Okay, thank you. The feedback came that you're not audible today. Sir, LHS in kinetic energy, LHS is kinetic energy and RHS is potential energy. Udit, if time permits, we'll do that. Okay, Udit? Are there any graph-based questions from this concept? Maybe, not specifically, I remember any. Okay, thank you. Okay. Sir, how do we know that G applies on the bob vertically? It's not like it's going vertically up. It's because this is where the ground is. And this is where, when we draw the free body diagram, mg acts. And because mg on Earth in this universe acts vertically downward, okay, that is why we consider that gravity is vertically downward at any point. So that is why it is safe to assume that the body is going to experience gravity only downward. Okay. Sir, can you please tell the formula in the? You have to rewatch the session because I have explained it already. What about vertical circular motion? What about it? किया ना solve vertical circular motion में भी तो law of conservation of energy apply करते थे ना. This is law of conservation of energy only applied there. Okay. We are not sure about other Earth if you are from. Absolutely, yes. So during collision, mechanical energy is not conserved, but when we take velocity of the system after collision, so after that mechanical energy is conserved because the collision is completed. Jay Kritik. Definitely the mechanical energy is not conserved in perfectly inelastic collision. That is why this expression is applied after collision is done. After collision is done, you see this diagram also. This is after collision. When the bullet and the block have become one body. This is m plus capital M mass. Okay, that is why I've written only m mass, the total mass of the system. Okay. Okay, guys. Yes, chalo bhai. This is done. Let's speak about head-on collisions now. ठीक है वंश जैसा तुम्हें सही लगे. Yes guys, so now we'll speak about oblique collision. Let's switch off the chart, focus for a few slides of theory. After that only problem solving. Practically the concept will be, or rather practically the situation will be different, but the technicalities of the situation is still the same. Means there is nothing technically that I'm going to teach you new today. It is only that the objects are now after collision they are going to not move along the same line. In head-on collision the bodies before collision, after collision were moving in the same line. But now when we speak about oblique collision, read the definition, all of you. It says that if the two bodies do not move along the same straight line path before and after the collision, then the collision is said to be oblique collision. Okay, one of the situations I'll show you. This is one of the situations. There is no fixed situation in oblique collision. Fundamentally, during collision, there has to be a two-dimensional path of the bodies. That means what two bodies should not move on the same line after the collision. As simple as that. Okay, so what we see here, guys, when you have body M1 moving with velocity U1 collides with body M2 moving with velocity U2, and obviously U1 is greater than U2 in this case, as per the diagram, then only the collision happens. Okay, so you can see that the line of motion of M1 and line of motion of M2 are not overlapping. So that is why after collision, they are not going to move in the same line. They're going to divert. They're going to go separate path. So you see that M1 is going with a velocity V1, M2 is going with a velocity V2. Their angles with their original path is also different. M1 is making an angle theta. Notice this angle, this is theta. And maybe M2 is making some other angle phi. Theta plus phi, any value. Okay, theta and phi could be any value. So right now what we are definitely sure that because this is collision, so conservation of linear momentum will definitely be applied. Okay, and because the forces which are acting on the system, they are basically assumed to be, what do we call it? The forces are going to be internal, not assumed they're internal forces, because we are considering that the situation has two objects only which are applying force on each other. There is no external force acting. F external is equal to 0. So we can say that COLP is conservation of linear momentum. Okay, guys. So conservation of linear momentum along x-axis and along y-axis. This is what is going to be new. Means what? Now because your bodies are not moving along the same direction, so you will have to look at the momentum of the system before collision along x direction and momentum of the system after collision along x direction, and do the same for the y direction also. So say, and in our situation, in our syllabus, we'll only have two-dimensional collision. We will not have 3D case. So say one of the axis is x-axis, another one is y-axis. So look at this, guys. If we speak about the direction, we have been given this as x and this as y direction already. So according to this case, we can say that along x direction, okay, along x direction, this body was moving, this body was also moving. So look at their momentum along x direction before collision, M1 U1 plus M2 U2. After collision, the component of V1 along x direction is V1 cos theta, so the momentum becomes M1 into V1 cos theta. Similarly, for this body also, the angle is phi, so velocity component on x direction is going to be V2 cos phi multiplied by its mass M2 V2 cos phi, right? Basically, you resolve the velocity vectors multiplied by mass, you get the momentum also. So this is basically your momentum conservation along x direction. But if you look at the bodies in the given diagram, as I said, every diagram will be different, every situation will be different, could be different. So before collision, both the bodies are moving only on x direction, so there is no y direction momentum. So that is why initial y direction momentum is 0. Okay, and after collision, the y direction momentum for the first body is M1 V1 sin theta and M2 V2 sin phi, equated both of them, right? This is the only foolproof thing that will be valid for two-dimensional collision. Only foolproof thing. Because after this, what is written is a condition that if this collision is elastic, which is going to be the case in 90 to 95% of the questions. So if this collision is elastic, then the kinetic energy will remain conserved. So you will just write the kinetic energy before collision and kinetic energy after collision, you will equate them. And one special case which I'm not deriving, I'm telling you, and you'll have to remember it, is when U2 is 0, the second body which is being collided with is not moving, and they both have the same mass also. If they have same mass, and if U2 is 0, then after collision, the two bodies are going to move perpendicular to each other. That means what? If I take this diagram once again there, I will say that the value of theta plus phi is equal to 90 degrees. That's what this condition says, and you will remember it. Okay. Remember, only when M1 is equal to M2 and U2 is equal to 0. Not deriving it deliberately, because not important neither from your school examination point of view, not from JEE point of view. You remember that whenever two bodies have same mass colliding in 2D and initial velocity of the second body is also 0, then the two bodies after collision will move perpendicular to each other. That means their angle of the direction is always going to be 90 degrees. Okay, guys, taking you back to the slide and opening the chat if you guys have anything to ask. Is this making sense to all of you? Definitely we'll see examples. I'll show you better examples for understanding of this part. Okay, we'll do patiently few examples. We will take less slides on this, but we will do quality problems today. Okay, everyone? Situation to situation will depend. Okay, this part will be valid for any collision. This part, the momentum conservation will be valid for any type of collision. Okay, everyone? Yes. So do forces change the direction in these cases? The bodies change the direction because of forces, definitely. Sir, can case be vice versa perpendicular? Yes, if the bodies are moving perpendicular to each other and they have equal mass, that definitely means that the two bodies, or rather, if the body after collision are moving perpendicular to each other, then we can definitely go back previous, and we can reverse the understanding. So we also have to apply the force concept. What is the force concept? Yeah, I'll show you that also. So ये y-axis वाला M1 V1 sin theta कैसे हुआ, all that. Arshad beta, chapter of vectors पे जाके vector resolution एक बार go through करना, you will understand. Okay, sir, if U2 is not 0, then they may be perpendicular, may not be perpendicular. Yes, this condition has to be foolproof. This condition has to be always valid to say that the two bodies are moving perpendicular. So what is maximum angle after collision? Maximum after collision could be, I don't know, maximum angle will be definitely less than 180 degree in such cases. Will be less than 180 degree for sure. सर वो दोनों अलग एंगल में ही क्यों जा रहे हैं? They can even go in the same angle. Definitely जा भी सकते हैं बिहान. वो बहुत कुछ डिपेंड करेगा वेलोसिटी पे, किस पॉइंट पे वो कोलाइड कर रहे हैं. Definitely 45 degree की possibility है बिहान, but not always. What if U1 is 0? Ah, shabash. What if U1 is 0? Would anyone want to tell the answer? What if U1 is 0? Shabash. Thank you for saying this. This was running in my mind. Sir, the last slide you have shown, we need to remember only the result. Yes, Manan, and this is the slide, by the way. Okay, sir, in head-on collision or perfectly elastic collision, and then masses of both objects are same case when the velocity of second object should be 0 or not 0. नहीं समझा क्या बोलना चाह रहे हैं? क्या बोल रहे हैं? हाँ हाँ, और इसकी velocity इंटरचेंज हो जाती है, वो उसमें सेकंड बॉडी का रेस्पॉन्स होना जरूरी नहीं है, कुछ भी velocity होने पे इंटरचेंज हो जाएगी. ठीक है, ठीक है, everyone, should we see some examples for better understanding? Angle will not be 180 degree between both of them after collision. Will not be 180 degree, वो possibility नहीं आएगी. 180 degree आना possible इसलिए नहीं है in this case, because if the bodies go 180 degree with each other, then the x direction momentum becomes 0, which is not possible because they have initial x direction momentum. That's why. ठीक है, चलो let's have a look at some example. Yes, definitely. चलो everyone, I'll show you some examples. Pay very close attention. You will understand it better, and if you understand this better, you will definitely be able to apply law of conservation of momentum in 2D. This type of cases. Okay, so what does this say? It's basically like a ball which is hitting the ground or any floor. It hits the floor and rise up. Okay, so we are being said that we have to find the velocity of the ball after collision if coefficient of restitution is E, and we are not being said, okay, assume partial elastic collision, means consider the most generic possibility, don't consider ideal case. So consider partially elastic collision, which means E is not equal to 1. Okay, E is some value between 0 and 1. Okay, so everyone, this ball is going to go hit the ground, will experience a force which is vertical from the ground, and it will start rising. Now, because the case is not perfectly elastic, that's why I'll not consider that the angle at which it hits the ground will be equal to angle at which it starts rising. I will say that angle at which it hits the ground makes the angle with vertical as theta, but after rising it makes an angle alpha. I'm not considering the easy case. Easy case would be theta angle it hits, theta angle it goes on. Okay, means I'm not talking about the two angles to be equal. Look at this diagram, everyone. So it hits at an angle theta, it goes at an angle alpha. So when the ball is going to move initially, it is making an angle theta. The diagram has given this angle, but when it starts rising, I've taken the angle to be alpha. And this y-axis is the line of impact. I showed you guys this is where the force on the ball is going to act. We have seen this situation earlier. I told you people that this is where the force on the ball is going to act. This is that normal force applied by the ground. Okay, our focus is not on this force. Our focus is on the momentum. So everybody, this is situation when the body is yet to collide the ground, and this is when it starts to go up or after the collision has happened. So just before collision, just after collision situation we are considering. So just before collision, the velocity is u. We are considering the ball is very close to the ground. Okay. So guys, if we speak about the initial momentum before the collision, so you can say that the mass is m, its x direction velocity. You can say that if the angle is theta with the vertical, then this becomes u cos theta, this becomes u sin theta. So horizontal component is m into u into sin theta. What did I do? I multiplied m with u sin theta. If you want to take it easy, we can do it this way also. Let's find out the initial velocity, u. U vector will find out. So this is u vector. It has two components. One is u sin theta. Yes, u sin theta. If I wrote u cos theta by mistake, u sin theta I cap is the x component, and that is along positive direction. Okay. For y component, it is u cos theta, and that is j cap. Okay, everyone. Should I write plus u cos theta j cap or minus u cos theta j cap? In the chat box, tell me quickly. Thank you. It is going to be minus because the body is moving along negative y direction. Y axis ka component is negative. Okay. Similarly, let's write down final velocity by considering angle alpha. So this is u sin alpha I cap. See that, u sin alpha. Okay, and I'm removing this 1 and 2 because it might confuse you as 2m mass. Plus or minus now. Plus or minus. Now I'll write plus because the body is going up. V cos alpha is along positive direction. Okay. Everyone, do you people remember that the force, or remember, can you see that the force acting on the body in x direction is 0? You see that? And that is why can I say that the velocity of the body in x direction will remain unchanged? Remember this part? Velocity in x direction remains same. Okay. So we can say, I'll do one thing, make it even easier for you. Momentum along x direction will remain unchanged. Okay. So Px initial is equal to Px final. Okay. What happened? Sir, shouldn't it be V sin alpha in V resolution? मैंने sin alpha ही तो लिखा है, V sin alpha and D cos alpha ही तो लिखा है. क्या तकलीफ है? जितने लोगों को ये कंफ्यूजन हो रहा है कि ये साइन क्यों है और ये कॉस क्यों है, फॉर ऑल दोस पीपल आई एम नॉट एक्सप्लेनिंग इट टुडे, आई एम टेलिंग यू टू, अच्छा ओ अच्छा हाँ ठीक है, वी okay, so Px initial is equal to Px final. We can say Ux will be equal to Vx, which means what everyone, mass तो cancel हो गया. Ux का वैल्यू क्या है? U sin theta and V sin alpha. Okay everyone, this is our equation number 1. What do I want? We want the velocity V. Okay Manan, I'll explain it after some time switching off the chart if you have any doubts. Okay, but along x direction we have done it. Along y direction, अभी थोड़ी देर पहले we solved the question. If you guys remember, a few moments back we solved this question: velocity of approach, velocity of separation, right? So here also, if we try to define the velocity of approach and velocity of separation, everyone, pay attention. We will say that E will be equal to velocity of separation divided by velocity of approach. The velocity which is taking them away, the ball and the ground are going away because of V cos alpha. Okay, and both of them are coming close because of U cos theta. So this is U cos theta. So from here, V cos alpha, this comes here, multiplies with E, becomes E times U cos theta. This is our equation number 2. Are we all clear with it? Make sense so far? Okay, hold your other questions at the moment, only look at the two equations. Do you understand this? Okay, so what do we want? We want to find out the velocity vector V. Can we say it is going to be V cos alpha I cap plus V sin alpha, sorry, ulta ho gaya. We have already written that. We have written here already. Why do we have to write it again? V is going to be the magnitude. Can I say it's going to be under root of V square sin square alpha plus V square cos square alpha? Correct everyone? Right? Awesome. U cos theta is the velocity because of which the body is coming down. U sin theta is not the velocity which is bringing the body close to the ground. U sin theta is only taking it parallel to the ground. That is why U cos theta is the velocity which is velocity of approach, and U cos alpha is the velocity responsible to take the body away from the ground. So that's why velocity of separation. Okay. So as per the diagram, now what we have is, have a look once again. We have got the velocities. This is E times U cos theta. This is U sin theta. Both the velocity components we have got. I'm going to put them here, and when we put them here, we can simplify this to get the answer. Okay. Yeah. So one is E times U cos theta, one is U sin theta. Simplify them. This is what we finally get. Do I need to memorize? No. Please don't memorize. Okay. We can also find out the value of tan alpha, which is going to be Vy by Vx. This is Vy by Vx. So you can always find this out. Okay. This is called line of impact. Okay. How the two alpha angles are equal? Are they, which two alpha angles are equal? What two angle alphas? क्या बोले जा रहे हैं? कौन से दो अल्फा एंगल? ये जो लाइन है इस पे ये एंगल अल्फा ये एंगल अल्फा नहीं होंगे क्या? ये दोनों पैरेलल नहीं है क्या? करस्पॉन्डिंग एंगल्स नहीं आएंगे? अच्छा, पूछना क्या उसमें? मैथमेटिक्स दैट यू नो फ्रॉम 10th स्टैंडर्ड। मैं समझा नहीं क्या? ये मैं एक चीज बोल देता हूँ, सबको बोल देता हूँ, मुझे मैथमेटिक्स के एंगल्स के नाम नहीं याद है। मैं ज्योमेट्री से काम करता हूँ। आई मे नॉट रिमेंबर व्हाट यू कॉल दोस एंगल्स, बट दे आर इक्वल और नॉट इज व्हाट आई कैन टेल यू। I do not know whether they are vertically opposite angles, they are corresponding angles, or what not. I do not remember their names as per mathematics theorems, but they are equal is what I can confirm. Okay. हाँ भाई, तुम्हें ज्यादा मालूम है, obviously you guys are studying mathematics, not me. बिल्कुल प्रदीप था। I'm planning to take micro courses for 10th standard. Chalo guys, one more similar type of question now. Now this time we'll solve it with a numerical approach. Okay, one more. Yes. Chalo guys, similar question, but this time you see angles values are given. So one of the angles is 45 degree. The velocity with which the body is coming is v, and then after collision it goes with the velocity v dash. Okay. So after collision the velocity is given as v dash. The angle which it is making with the velocity is making with the vertical is theta dash, or here angle is theta. So actually they're asking for the angle of reflection. That means they're asking for the angle theta dash. Though you can directly apply it here. Tan theta by पहले check कर लेते हैं. Will it work or not? Okay. Tan theta dash will be equal to tan theta by e. So tan 45 degree divided by e, which is 1 by root 2. I'm not writing this so that you remember the formula. Please don't remember the formula. Okay. So tan 45 degree is 1 and 1 by root 2 it is, which will go in numerator will become root 2. So theta dash should come out to be tan inverse of root 2. वैसे तो question यहीं खत्म हो गया है. Question यहीं खत्म हो गया है, but we will still do it. Okay. This is done here, but we'll still do it. Okay. So look at the approach. You will find the similar approach. So if we speak about the components along x direction and along y direction. So everyone, if we look at the x component, they have written it here. Y component, I've written it separately once again. So if we speak about x component, the x component of velocity is going to be the cos 45 degree component here. So v dash cos theta dash. Okay, v dash cos theta dash, and this is v cos 45 degree. Equated both of them. Just a second, मैंने गलती की हुई है, मैं correct कर देता हूँ, मैंने कुछ गलती की हुई है. Okay, yes guys, so this is basically y direction, then this is x direction. Okay. Okay, so this is along y direction. So along x direction the velocities remain unchanged. So that is v dash sin theta dash equal to v sin theta. They are sine components. If we look at, this is basically the cos component. Sorry, because of the size of the diagram I might have written it incorrectly. Let me properly write it for all of you, because the angle is given with vertical, not with horizontal. So this angle is given as theta. So this is v cos theta, and this is v sin theta. We just did that also. And similarly, this angle is theta dash. So this is going to be v dash sin theta dash. This is going to be v dash cos theta dash. So cos component is basically y component. Cos component is y component, where velocity of approach and velocity of separation will go. Okay, and x direction is sine component. So v dash sin theta dash equal to v sin theta. No change in that velocity. Theta value is 45 degree. So that's why v by root 2. This is our first component. Okay, guys. In the second case, velocity of separation is e times velocity of approach. That's what we write. E is velocity of separation. Velocity of separation is v dash cos theta dash. Velocity of approach is v cos theta. This goes here. V dash cos theta dash you see here is e times v cos theta. Theta value is 45 degree. You put the value of 45 degree. E ka value is also given as 1 by root 2. So this is the value of v by root 2, and this is e value. दोनों multiply होते हैं, we get v by 2. This is your equation number 2. I will just take this off because we already have got both of them. Okay, and from here everyone, we have the x component of velocity after collision and y component of velocity after collision. So under root of vx square, vy square is v square by 2 plus v square by 4. That comes out to be root 3 v by 2. And they're asking for the angle. So now we have the y component also, we have the x component also. So we actually don't need to find this value. We can directly talk about the angle as v by dash upon vx dash. So v by root 2 by v by 2, we got the same answer which we got in the previous case when we generalized it. Okay, so I don't think there's any trouble here, because everything that we derived here, this time the values are being directly used. In place of theta, we have got the value as 45 degree. In place of alpha, we were supposed to find the value, and that's why we got it here. Okay, so after solving generalized way, this looks like relatively much easier. Okay, so this is done. Cool. Sure guys, so we have already gone past 1 hour of the session, so that's why now a series of questions will start for all of you guys to try. I will keep on giving you hint, I will keep on helping you guys out. This is the first question. I've given you the diagram, I've given you the condition that you were supposed to remember, and it's a very easy question to start off with. Question says that you have two objects A and B, particles. They have the same mass m also. A is moving along x-axis with a speed of 5 meters per second. B is also there but at rest. So B is at rest. A is moving with some velocity that is 5 meters per second, and they undergo a perfectly elastic collision also. That means what? M1 is equal to M2 and U2 is equal to 0. So after collision, the angle with which they go is going to be 90 degree. That's what the condition of note is also given. Question is asking us that after collision, particle A gets scattered through an angle 60 degree. So what will be the direction of motion of B, and the speed of A and B after the collision is being asked. Okay guys, giving you full complete 2 minutes. Apply law of conservation of momentum. Remember, the initial momentum, I should say that momentum along y direction throughout is 0. Why? Because before collision, there was no momentum along y direction. This body is moving on x direction, this body is not even moving only. So there's no momentum along y direction before and after collision, is what I can say. Conserve, definitely. Time for 2 minutes starts in 3, 2, and here we go. Almost 1 minute is gone. You still have 1 more minute left. Take it easy, easily solve it. Try to apply concepts slowly, steadily. Okay, try to write momentum along x direction, try to write momentum along y direction. By that only you'll be able to get it very easily. Along x direction, there is momentum before collision, there will be momentum after collision. There is no momentum along y direction in the beginning. So after the collision also, when the momentum will come, the summation will be equal to 0. That's what it is. Okay, last 10 seconds now. Okay, and time's up, everybody. Okay. So the correct answer to the question is option A. And let's see the approach. So without any hesitation, if they are both going to move at 90 degree, you can say that body B is definitely going to go at angle 30 degree without any problem, because the angle between both their motion has to be 90 degree. Okay, guys. Now if you write the momentum along x direction, conserve. So initial momentum of A is m into, say, the velocity is u. The other body has zero momentum. So momentum of the first body, momentum of the second body before collision. After collision, velocities are v1 and v2. So you will definitely have to resolve them. So when you will resolve, you will have mass of the first body, its x direction velocity will be v1 cos 60 degree I cap. Actually, I cap because we are writing it on x axis only. So m v1 cos 60 and m v2 cos 30 degree. And both of these bodies will have the momentum along positive x direction only. As per the direction of the diagram, their momentums will be along x direction. That's why you're adding. Okay, so m cancels. U value is given, by the way. So I'm not writing the mathematical aspect here, but what you have is u equal to v1 cos 60 plus v2 cos 30 degree. That means u will be equal to v1 by 2 plus root 3 v2 by 2. That's one equation. Or if you further simplify this, v1 plus root 3 v2 will be equal to 2 times u. This is equation number 1. And along y direction, interesting case, along y direction, this is going to be v1 sine 60 degree. This is going to be v2 sine 30 degree. Right? And you can see both of them are in the opposite direction, right? So initial momentum along y direction is 0. So finally will also be equal to 0. How will you write it? v1 sine 60 degree. This is positive direction, and minus v2 sine 30 degree. Why minus? Because this one is going in the negative direction. So this shows that v1 sine 60 is root 3 by 2 will be equal to v2 sine 30 is 1 by 2. That means v2 is root 3 times v1. So this is your equation number 2. You have equation number 1 here, equation number 2. Two equations to one more. Simplify. That's it. Okay. So we had this v1 plus root 3 v2 equal to 10, and from the other one, v2 is v1 root 3. Right? v2 is root 3 v1. Simplify both the equations, you will get the value of v1 and v2. Okay, everyone? Good. Calculative, definitely calculative, but approach, if it was right, if your approach was also right and you could not complete your calculations in the time given, that's still fine, that's still acceptable. Okay, if you are thinking in the right direction, you got this, and if you got this, these two equations matter. Okay, so next question for all of you. This is from JEE Main 2020, last year the question it is, and diagram is already given. It says that the particle, there is a particle of mass m. This is that particle. It is moving with a velocity u I cap. That means it is moving along x direction. It collides perfectly elastically. That means there is no loss of kinetic energy, and it's going to collide with a mass which is 3m. So, and the mass is also at rest, but the masses are not equal this time. So you cannot say that the angle between them after the collision is 90. No, it is definitely can't be said directly here because the masses are not equal. But it is said that the mass m starts to go with a velocity v j cap along y direction. It has started going. So maybe 3m mass will start going in some other direction, making an angle theta with a velocity v dash. So question is asking us that the velocity v in terms of u will be how much? Means mass m only, its final velocity in terms of its initial velocity. So again, before collision, 3m mass is not moving and m mass is moving along I cap direction. So that's why there is no momentum along y direction. That's first hint. In x direction, okay, just a second. In x direction, the momentum will definitely remain conserved, just like y direction also. And because it is perfectly elastic collision, kinetic energy of the system will remain conserved. You will require that equation. Okay, start solving, guys. I'll give you 3 minutes for this one. And your time, first minute starts in 3, 2, and here we go. Start solving. After 1 minute, I'll start the timer. For 2 minutes, I'll give you the timer after this 1 more minute. That means in total, you get 3 minutes. And 3, 2, and here we go. Last 15 seconds now. Let's see. Well done. Fastest angle list was awesome, but overall not so impressive. So everybody, along y direction, there's no momentum before collision, and after collision will also not be there. And if we look at the velocities initially and finally v and uv dash and u. So we can write the kinetic energy equation also. Half mu square is the kinetic energy before collision, only possessed by this body. 3m mass is at rest. After collision, m mass kinetic energy half mv square, 3m mass kinetic energy half into 3m into v dash square. M obviously gets cancelled. So what we have is half and m both get cancelled. So u square equal to v square plus 3v dash square. Right, everyone? This is equation number 1. And definitely we want the value of v in terms of u, so v dash has to be eliminated. So we'll take the help from law of conservation of momentum. Along x direction, only first body has momentum, and after collision, the 3m mass only has that momentum. Why? Because m mass is purely going along y direction now. So only component that I see is 3m, or let's just write the velocity v dash cos theta, and that too of 3m mass. And here along y direction already mv is there, and we also have v dash sin theta. This is also of 3m mass. So along x direction, you have u equal to 3v dash cos theta, and along y direction, I can say that initially it is 0, finally it is mv in the positive direction, and 3m v dash sin theta, 3m v dash sin theta along negative direction. So we have equation 2 and 3. Using them, I can actually eliminate v dash maybe, or if I square and add them, I'll get u square v square. Okay, I can do one more thing. I can replace. Why should I add them? There's one point that I want to highlight today for all of you guys. If you want to eliminate something like v dash in this case, and it is also coming with cos square, cos theta, and sin theta. If ever you see something of this sort, where one of the same component, or one of the component of the same quantity is cos, the other one is sin, and you want to eliminate that component also, then it is advisable, if you don't need the value of theta, to square and add it. Means what? If you will square this component, it will be something cos square theta. This will be that same something sin square theta. If you add both of them, 3v dash square will be common, and sin square theta plus cos square theta will become 1, which has happened here, by the way. If you square this, it is 9v dash square. It is also 9v dash square, but cos square theta plus sin square theta becomes 1, and it gets eliminated. Okay, and that is one of the ways of approaching questions at times, which will save a lot of time for you. When we do that, you see u square plus v square on the left hand side, and on the right hand side we have only 9v dash square. Okay, we already had a v dash from here, equation number 1. So from here, v dash square comes out to be u square minus v square by 3, and that's what we are putting up here. Okay. V dash square is put as u square minus v square by 3. This is cancelled 3 times and further simplified. So let me show you if you want how it gets simplified from here. We have u square plus v square equal to 3u square minus 3v square. U square come here, v square goes here. So 3 plus 1, 4v square, 3 minus 1, 2u square. That means we have root 2v equal to u, v equal to u by root 2. Okay, hope it's clear for all of you. And that is what the correct answer is. V equal to u by root 2. Okay, good. Sure, we'll see one more question, everyone. This one is also from JEE Main 2020, and the question is actually not from, not exactly, it will not require you to apply the concepts of oblique collision, because the collision is head on here. Question says that we have a block of mass 1.9 kg. Okay, this is that block of mass 1.9 kg, which is at rest, and it is placed on the edge of a table. So it is placed on a table maybe. Okay, so this is basically the edge of the table. Okay, so on this table, it is placed at rest. Then what happens? And also at a height of 1 meter, a bullet of mass 0.1 kg comes and hits the block and sticks to it, which means what type of collision? Perfectly inelastic collision happens. Now, if the velocity with which the bullet was approaching is 20 meters per second, this is the velocity with which my bullet was approaching the block, okay, and it sticks with it, then the kinetic energy just before the combined system strikes the floor will be how much? Assume there is no rotational motion and there is no loss of kinetic energy after the collision is completed. So the point is, guys, I'll first explain you the question more neatly so you understand how to approach it. You have an object which is placed at the table. This is where it is maybe. Doesn't matter whether it is on the edge or not. They have just said it to maybe confuse you, to give you more thinking, to make you more think, make you think more about the question. So this u velocity is given, m mass is given, capital M is given, and the velocity u2 is 0. u1 is given, u2 is 0. Now what happens? This block is being hit by the bullet. The bullet hits it. The total mass becomes m plus m, and the velocity with which they both start moving is v. This everything is still happening on the table. Table is frictionless. If it is not said, you will still assume it is frictionless, but might have said already. They have not said it. So you will assume that there is no friction unless it is given. You will always assume that. So this system starts to move. They reach here, and because there is no friction, the velocity of the system remains the same. The mass m plus m still has the same velocity. Now, because it is already at some height h, from here they will basically fall, maybe follow a parabolic path. Projectile motion happens, and you may or may not require to use the concept of projectile motion. Finally, when they hit the ground, when the height becomes 0, what is the velocity of the combined mass? I guess that's being asked. Question is asking what is the kinetic energy just before colliding? So maybe v dash becomes the velocity, m plus m is the mass. Just before collision, how much is the kinetic energy? Ke dash. That's being asked. Hope the question is clear. This is given to us as 1 meter. So what you will be first trying to find out, you will try to find out how much is the velocity of the combined mass just after collision, and then from this position A to this position B, you will apply law of conservation of energy. Law of conservation of mechanical energy, and energy will remain same here because there is no loss of energy happening after the collision is completed. So from A to B, no loss of energy happens. Kinetic converts to potential, potential converts to kinetic. Those kind of situation happens. Okay, guys. So I hope the situation is clear, and I'll just give you the values here only. 1.9 kg, 0.1 kg. Just no, I can't give it to you there because you have to solve the question. So I'm giving you people 2 minutes, and it is definitely doable in 2 minutes, and the time starts in 3, 2, and 1. G value is given as 10 already. There is no oblique collision in this case. One minute is gone. I cannot change the slide also once the quiz is on. That's why I can't show you that slide. All you have to do is find out the velocity just after collision, both the bodies together, and then law of conservation of energy. The total mass after collision becomes 2 kg, so life becomes easier calculation wise. So I think only part where you will require efforts is to find out the velocity of combined mass just after the collision. Okay, 0.1 into 2, that is 2 equal to 2. That is also easy actually. Take back my words, it's easy. Doesn't deserve 2 minutes actually. But I think this is our second last question. Okay, so this is better than before, better than the previous one. Okay, so everybody, if you have small m as 0.1 kg, capital M as 1.9 kg, and this value as 20, then you will say that initial momentum is m into u and final momentum is m plus m into v. So v will be equal to 0.1 into 20 divided by the total mass, that is 2. This cancels 10 times. I have 1 meter per second is the velocity of the combined mass. Very good. Now energy at A equal to energy at B. At A, the energy is half m plus m into v square plus m plus m into g into h. This is energy at A. And energy at B is only half m plus m into v dash square. And actually we don't need to write that also. We just need the kinetic energy only. So kinetic energy final plus zero potential energy. So we need to find this value. So life would be very simple with just the mathematics required. So we got the velocity 1 and just writing this final equation. Initial potential energy, or I will solve it in my own way, the way I always approach it. Energy at A will be equal to energy at B. At A, there is potential energy of the mass 2 into g into h. Kinetic energy half into 2 into v ka square will be equal to kinetic energy at B plus zero potential energy. So Kb will be 2 into 10 into h ka value 1. 2 and 2 cancels, 1 ka square. So what do I have here is 20 plus 1. So Kb, the final kinetic energy is 21 joules. 21 joules. Okay, so we just needed to find out this whole value, initial kinetic energy plus potential energy. Okay, chalo, the last question. It says that two particles of equal mass m have respective initial velocities u I cap and u by 2 I cap plus j cap. Means you can actually look at this velocity as u by 2 or half of u I cap plus half of u j cap. This is what it is written. So you have the initial velocity of both the masses. They collide completely inelastically. Okay, that means they stick together, and the energy lost in the process will be how much? That means it is asking you to find out the loss of kinetic energy, which is k initial minus k final. Why initial minus final? Because energy is lost. You can actually find out final minus initial. That value will come out to be negative. That will represent the loss of energy. Okay, guys. So definitely energy potential energy is considered to be same throughout the situation. Only kinetic energy is being lost. It is at the same level, so no change in potential energy. More importantly, the momentum of the system initially and momentum of the system finally, as I said, because the situation is collision, will always remain conserved. Okay, everyone. So basically, you need to find out the final velocities of both the bodies. That's what it is. Yes, you will require the final velocities of both the bodies, and because it is perfectly inelastic collision, so the combined velocity will be same. Giving you people 3 minutes again. Your time for first minute starts in 3, 2, and 1. Come on, start solving. I'll start the timer for 2 minutes after 1 minute is gone. Timer starts after 30 seconds. Timer starts after 20 seconds. Timer after 10 seconds. 5, 4, 3, 2, 1. Timer starts. You know that both the bodies after collision will move together as one body of mass. I'm not able to see the mass of the other body, so it can't comment right now. It looks like both of them are of same mass. Two particles of equal mass. So both have same mass. So both the bodies together stick together and become a body of mass 2m. Forty-five seconds more. Last 15 seconds. Okay, last 10 now. Come on, people, mark your answers. If you like my name, then comment. If I could comment, you would not like it. I would comment you would not like it. Anyway, so the initial velocity of first mass is given, minus velocity of the other mass is also given. We know that m into u1 plus m into u2 will be equal to 2m mass and v velocity. Why do I write it like this? Because now it is again a two-dimensional case. That's why. So have a look. If we write the momentum conservation, as I said, m into u1 plus m into u2 equal to m1 plus m2 into v. So just put the expressions here. M u I cap, m into u by 2 I cap plus u by 2 j cap, and this thing is going to be equal to, and equal to sign is missing, is 2m v vector. So v vector comes out to be, after cancelling m, you get it as, after simplifying this, I want to simplify it. You have m u plus m u by 2 I cap. From here, one more u by 2 comes, right? Plus m u by 2 j cap is equal to 2m v vector. So what do I cancel? First of all, m goes throughout. And now I have u plus u by 2 is 3u by 2 I cap plus u by 2 j cap is equal to 2v vector. So v vector, divide the side by 2, both the sides, you get 3 by 4 u I cap plus u by 4 j cap. Okay, so we have a vector. You can find out its magnitude by under root of vx square plus vy square. So squaring this, u comes out. Square of this is 9 by 16. This is 1 by 16. So 10 by 16. So root 10 by 4. This is what we get. So initial velocity half mu square plus the momentum of, or rather the velocity is u by 2 I cap plus u by 2 j cap, comes out to be u by root 2 under root of vx square plus vy square. Simplifying this, this is the initial velocity, comes out to be 3 by 4 mu square. Final kinetic energy after putting the velocity. Okay, it's keep becoming maybe too much for everyone. So let me write things step by step one more time for all of you. We have the velocity, final velocity of both of them together. Okay, अब क्या करेंगे? We will find out the initial kinetic energy of the system, and for that I will require the velocity of both the bodies. So half m u1 square plus u2 square, because mass is same, that's why half m is taken out. Okay, now the thing is, guys, half m, u1 is u only, so square gives you the value directly. But the point is, if you look at this velocity, the velocity second one, if you try to find out the u2 magnitude, it will be u square by 4 plus u square by 4 in under root, which is basically u square by 4 u by 2 root 2. That means this will be u by root 2 overall when we simplify this. So square will be u square by 2. You can look at it this way also. This is u square by 2, which is the magnitude of u2. So let's put that here, u square by 2. So this comes out to be 3u square by 2. 2 and 2 multiplies. This will be 3 by 4 mu square. That's the initial kinetic energy. And the final kinetic energy, everyone, will be half. The total mass is now 2m, and the velocity is v square. This is the velocity v square, squaring this value. So first of all, 2 and 2 cancels, m, and square of this value will be u square into 10 by 16. That means this comes out to be 5 by 8 mu square. Good enough. So what is the loss? Loss is k initial minus k final, right? Ke initial minus ke final. So mu square comes out 3 by 4 minus 5 by 8, or we can say it as 6 by 8. 6 minus 1 is 5. So answer is mu square by 8. That's our answer. 1 by 8 mu square. Okay. So this is the official end of the session also. Before I open the doubt panel, okay, before I open up the chat, let me show you the leaderboard. First of all, congratulations to all those who made it to the leaderboard today. Well done. Today's session is where I can say now the things are looking a bit, more, I would say, challenging. Yes, the right amount of challenge which we expect from JEE kind of examination. So this one had those level of questions where the topic itself demands you to be very cautious while solving it. So special congratulations to all those who were able to crack questions today. Well done, very well done. Okay, today's session, after a very long time, we have done really a session where efforts at JEE level are required. Okay, so yes, everybody, you deserve this. Great job, well done. And this one also. Fine. So this is officially the end of the class. That way, those who do not have any doubt, they can exit the class. Class teachers, if you are done with your doubts, you can also exit the class. Okay, everybody. Suri sir ka bhakt kaun hai bhai? Yes, Larry, definitely. There will be projectile motion. That's why we are only speaking about the small instant when it hits the ground and goes off. It's only valid for that small fraction of time. It should be final minus initial. Yes, Anshu, it should be final minus initial, but then it will be negative. The value will come out to be negative. Okay, leaderboard already shown. Yes, Riddhiman. Yes, you are. Sorry, I'm not able to understand where exactly we are heading to. Right from what? Right to the ground. Okay. But air also is consisting of molecules, particles. So that's called shock wave. Because there is a strong impact which has happened. That impact is being transferred to the nearby molecules of that impact circle. Those nearby molecules start moving faster. They collide the next molecule. They collide the next molecule. They collide the next molecule. A chain of collision happens. Eventually, like this. That depends upon the velocity of the particles after collision. Absolutely. Overall momentum पे depend करेगा. Yeah. Okay. No, sir. In a projectile motion, can we use EA equal to EB always when there is no air friction? Yes, Nihal. Absolutely. As long as there is no non-conservative force, you can always use it. Always. So when particle explodes at highest point of projectile, then what happens if one mass comes to rest? The other mass will carry that momentum. Whatever the momentum the mass had. Here, if m mass is there, it breaks into two pieces. Say this is m1, this is m2. Whatever be the value, you are saying this comes to rest. So this fellow will have to continue. So if this has velocity u cos theta, this will have 2u cos theta, so that the entire momentum, sorry, not 2u cos theta, that will be dependent on the mass of m2. So this will carry on with some velocity v dash or v, but overall this momentum and this momentum will be same. सर आपने इनिशियल माइनस फाइनल क्यों लिया rather than, अरे यार अंशुम क्या एक ही बात को बार-बार पूछे जा रहा है यार, बोला तो मैंने you can take it as final minus initial also, you can take it as final minus initial also, but that will come out to be negative and negative will represent loss, तो मैंने नेगेटिव में लिखना था इसलिए उसको इनिशियल माइनस फाइनल किया। और कॉमन सेंस से सोचो, if there is something which is reducing then definitely its initial value is more than the final value, so what is the loss, how will you calculate it? Now you're not spamming, you are actually asking the same question again and again, which has been answered, not that I don't like if you post it again. Sir, if is v sin theta equal to v double dash sin theta dash and v cos theta क्या है, क्या बोले जा रहे हैं? Hridaya, do you have a microphone? Please connect. Sir, can you explain the second question of JEE main of 3m mass? 3m mass वाला question, ये वाला. Yes, Irfan. Which part did you not understand? If you understood the law of conservation of energy, after that what we did, in the x direction, this mass has u velocity, the other mass has no velocity, so 3m mass has zero velocity, so you need not write it only because it has zero velocity. Okay, so this is x direction momentum, this is px written. From here we get u equal to 3v dash cos theta. Similarly along y direction, there was nothing which was moving along y direction before collision, so that's why the momentum is zero. Correct. So after collision, this has momentum and this has momentum y direction. Hridaya, your microphone is not working. Not exactly, Aradhya. So this is not correct statement to say, because in 2020 JEE examination, when it goes online, it is conducted 4-5 days. It is conducted 4-5 days. Like right now JEE is going on, it is already conducted 2 days. Tomorrow is JEE examination, day after tomorrow is also JEE examination. So definitely on 4 days, same topic questions will come multiple times. It's not on the same day. Okay. Sir, why 9 is there in the last line slide? Last line is this one. क्योंकि स्क्वायर किया ना मित्र, स्क्वायर करोगे तो इसका स्क्वायर क्या मिलेगा? 3 का स्क्वायर 9 होता है। निहाल, sir, what if when the particle is coming at an angle and after hitting ground it breaks into two pieces, that two part move up with different angles, still the momentum will remain the same, you will write their momentum along x and y direction, situation will remain the same. Okay. Yes, Vihan, good evening, tell me. I am good. Okay. I know. Huh. Mm-hmm. Mass of 10 kg वर्टिकली हैंग कर रहा है। समझ गया। ये कौन सा वाला 60 है? ये वाला। और ये रुको, मैं समझ गया तुम क्या बोल रहे हो। अरे मुझे मालूम है तुम क्या बोल रहे हो, बस ऊपर वाला 60 है, नीचे वाले स्ट्रिंग का 60 है, मतलब ये ऐसा है, ये ऐसा है ना, ऐसा कुछ है, ये भी नहीं है, किधर गया भाई ये? विहान, ये वाला क्वेश्चन एंड में लेंगे क्योंकि लॉज ऑफ मोशन का क्वेश्चन है। ठीक है, वेट करना थोड़ा, मैं थोड़ा आज की क्लास के डाउट ले लेता हूं पहले। यस मैडम, बोलो। यस टेल मी। मैं बहुत सारे रिफ्लेक्शन के क्वेश्चन है, ये वाला नहीं, ये नहीं था, सॉरी। वो न्यूमेरिकल वैल्यू वाला है या नॉन न्यूमेरिकल वैल्यू? ये पहला, हाँ, ये देख रहे हैं, कॉन्स्टेंट नहीं है, जीरो है, क्योंकि फ्रिक्शन भी नहीं है और ग्राउंड जो है वो वर्टिकली फोर्स लगा सकते हैं। लास्ट टाइम भी तुम्हें समझाया था मैं, बाय द वे। अभी तुमने भी साइड डायरेक्शन में फोर्स क्यों नहीं है, मैंने तब भी समझाया था कि क्योंकि कोई भी सरफेस जो है वो अपनी सरफेस से परपेंडिकुलर फोर्स लगाती है। दैट्स व्हाई मैं फिर वही बोलता हूँ, तुम मैथमेटिक्स पे मत जाओ कि अल्टरनेट होते हैं या फिर करस्पॉन्डिंग होते हैं, तुम ज्योमेट्री पे जाओ कि वो है या नहीं है वैसा सिचुएशन। मतलब ये है कि ऐसा हो सकता है कि दो एंगल तुम्हारे नहीं स्लाइड आते हैं, ये मान लो ये दोनों लाइन पैरेलल है, ठीक है, और एक एक लाइन डाल दिया मैंने इधर, तो क्या ये दोनों एंगल इक्वल होंगे? अब इनका नाम कुछ भी होंगे, इक्वल होते हैं ना, ठीक है। उसके अलावा अगर मान लो मैंने इन दोनों को कनेक्ट कर दिया, तो क्या ये दोनों एंगल इक्वल होंगे? होंगे ना। तो ये दोनों सिचुएशन दिखाई देगी हमें यहाँ पे हमारे डायग्राम में, यहाँ पे वो पैरेलल वाली सिचुएशन है और यहाँ पे ये अल्टरनेट वाली सिचुएशन है। अरे मित्र, ये है वो जो तुम समझ नहीं पा रहे हो, ये एंगल्स ही हैं, थीटा थीटा, ये दोनों एंगल्स भी एक दूसरे के बराबर होते हैं ना। ठीक है, तो बस ड्रॉ नहीं किया मैंने। ठीक। प्रोजेक्टाइल में नहीं होता, सिर्फ हाईएस्ट पॉइंट पे होता है, बट एक्सटर्नल होता है ना, एक्सटर्नल फोर्स होने पर मोमेंटम कंजर्व नहीं होता, और सिर्फ हाईएस्ट पॉइंट पे कंजर्व इसलिए होता है क्योंकि हाईएस्ट पॉइंट पे मोमेंटम ही एक्स डायरेक्शन में होता है पूरा, इसलिए ये जो सिचुएशन है ना, ये हाईएस्ट पॉइंट पे वैलिड होती है। बिल्कुल, क्योंकि फोर्स है ही नहीं एक्स डायरेक्शन में, इसलिए वेलोसिटी कंजर्व है। हाँ, मैंने बोला है मोमेंटम कंजर्व होता है प्रोजेक्टाइल के दौरान। ये अभी किसी ने पूछा कि हाईएस्ट पॉइंट पे जाके बॉडी दो में टूट गई, ब्रेक डाउन हो गई, वही बोला था एक्सप्लोजन वाला केस, एक्सप्लोजन हो गया तो मोमेंटम कंजर्व। हाँ, क्योंकि वो सिंगल बॉडी जा रही है तो उसका क्या मोमेंटम कंजर्व करूँ, उसका मोमेंटम हमेशा चेंज होता है प्रोजेक्टाइल मोशन में, तो क्योंकि एक्सटर्नल फोर्स लग रहा है क्या। लीनियर मोमेंटम कंजर्व नहीं होगा सिंगल बॉडी का कभी भी। होगा अगर तो उस पर कोई फोर्स लगेगा नहीं थ्रू आउट इट्स मोशन। गुड नाइट। अरे हाँ रे मेरे भाई आजा। हाँ निहाल टेल मी विच क्वेश्चन। फर्स्ट वन हाँ जस्ट a minute, it takes a lot of time nowadays, that's why. Yes, what was the question? So this body, you can't see the slide right now. Why? So you see when the ball is here, position one, it has two components of the velocity. One is horizontal, other is vertical. Which component is responsible for the ball to come and hit the ground? So that is velocity of approach. Why? Because without that velocity, the body will not even come close to the ground, and no collision will happen. If this will be a gravity-free space, the ball will just go like this. So it is vertical component which is bringing the ball down. Yes. And if the question would have one wall here also, the ball will collide with the ball, then the x direction component will be the velocity of approach in that case. If you start looking at the diagram by turning your head 90 degrees clockwise, then you will call that velocity component to be x component instead of y. So it is only the perspective which is different. But what is important right now, that which are the two bodies which are colliding? One is ball, other is the floor. What is that velocity component which is bringing them closer and taking them away? So v cos u cos theta is bringing them closer, agree? And v cos alpha is taking them away. So velocity of approach u cos theta, velocity of separation v cos alpha. The first question today. First question today. Huh. Yeah, absolutely. If the same question comes with numerical value, they ask you after 10th collision, what will be the height of the body? I just put the value of n as 10. That's why I derived it. Okay. Cool. That's nice. Okay. Okay. Hey, where is Mustafa? Mustafa Ali, are you here? No Mustafa today. During collision, we always say external force to be zero. We don't take it. We see if it is zero or not. So today I'm not able to solve all the questions. Is it okay, sir? I will watch replay and practice again. Absolutely, Manan. Absolutely. It is not every day is not same. Every day even Virat Kohli doesn't make centuries. He's been not making centuries for a long time though. Sir, it requires infinite practice. Yeah, you can say that. किधर है अभी और कौन है? Yes, good night, Harshita. Tomorrow is my birthday. अरे all happy birthday and best wishes in advance. Happy birthday in advance. किधर गया विहान? विहान इधर ही है. चलो आ जाओ. हाँ तुम तो दिख रहे हो लेकिन लग नहीं रहा तुम्हारी कॉपी दिखने वाली है. दिखाओ. हाँ हाँ. By the way, you are the first question जिसको first person जिसको मैंने आज तक अनकैम किया है. दिखाओ. अरे ये है और लेफ्ट वाला 60 है, राइट वाला 30 है और मास कितना बोले 10. ओके ठीक है. T2 कौन सा वाला है? 30 डिग्री वाला. डोंट गेस, यू हैव द क्वेश्चन इन फ्रंट ऑफ यू. देख के बताओ. तो ये 10 kg मास है और ये एंगल 60 डिग्री है. नहीं नहीं सही बोला मैंने. दूसरा एंगल 60 है. यही 60 है पक्का. नहीं 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 यार. हाँ ये एंगल 60 है और ये 30 है और इधर टेंशन T1 है, इधर टेंशन T2 है. ये T2 है और ये T1. डजंट मैटर वैसे तो ठीक है. अपने को सारी टेंशन की जरूरत पड़ेगी और ये 10 g हो गया. ठीक है. तो क्लोज करके वापस मैं अनम्यूट करता हूँ. इट्स लेंदी, डेफिनेटली इट इज लेंदी. हाँ विहान. तो है तो ये बहुत ही स्ट्रेट फॉरवर्ड, थोड़ा लेंदी है. ये एंगल 30 डिग्री है, ये 60 डिग्री है. जो अभी मनन को समझने में तकलीफ हो रही थी वो वाले एंगल्स होंगे. ठीक है. तो ये हो जाएगा T1 कॉस और साइन. नहीं नहीं जो साइड एंगल बनाती है वो कॉस होती है हमेशा. ठीक है. ये रहेगी T2 कॉस 60 डिग्री, जैसे T1 कॉस 60 डिग्री और ऊपर दोनों आ जाएंगे. T2 साइन 60 भी आएगा और कौन आएगा T1 साइन 30. ठीक है. ये T1 है ना. हाँ ठीक है. और इधर से आ रहा होगा T3. क्या मैं बोल सकता हूँ T3 का वैल्यू 10g के बराबर होना चाहिए बिकॉज़ सिस्टम इज दैट टेस्ट. तो ये तो 100 हो गया. ठीक है. डायरेक्टली g का वैल्यू लिख दिया मैंने. तो क्या मैं बोल सकता हूँ अगर पॉइंट P को भी इक्विलिब्रियम पे रहना है, पॉइंट P को भी अगर इक्विलिब्रियम पे रहना है तो ये ऊपर के फोर्सेस और नीचे का T3 भी बैलेंस होने चाहिए. तो एट P T2 sin 60 प्लस T1 sin 30 should be equal to T3 which is equal to 100. तो ये हो गई इक्वेशन. सो ये एक इक्वेशन हो गई. और दूसरी है x डायरेक्शन पे. x डायरेक्शन में T2 cos 60 should be equal to T1 cos 30. बस तो दो इक्वेशन दो सिंपलीफाई कर लेना, आंसर आ जाएगा. T1 निकालना है, T2 निकालना है, कुछ भी निकालो. गॉट इट ना. तो सिंपली ये मैं बोलूंगा वो है फोर्स बैलेंसिंग का क्वेश्चन है, नथिंग एल्स. नहीं मर्जी यार. अपना क्वेश्चन के अपने तरीके हैं. तो मैं कंफ्यूज करने के तुम इसको 30 बोल दो, इसको 60 बोल दो, एक ही बात है. मैथमेटिक्स है ये. ज्योमेट्री के साथ खेलना तो यार एग्जामिनर का काम है और तुम्हें कंफ्यूज होना करना उसका काम है. तुम्हें कंफ्यूज नहीं होना है. दैट्स द थिंग. नहीं दिया तो समझ थोड़ी कि मैथ्स नहीं काम करेगी. मैथ्स तो मैथ्स है. ये तो 30 डिग्री होगा ही होगा. तो वो चाहे दे या नहीं दे मुझे तो पता ही है. दैट्स इट. है ना. सब्जेक्ट कौन से क्वेश्चन होते हैं? सारे तो अच्छा न्यूमेरिकल वाले. इसमें ऐसा कुछ है नहीं वैसे कि वो वाले नहीं होते या नहीं होते. मतलब कोई भी चैप्टर अगर अच्छे से प्रिपेयर होगा तो दोनों ही हो जाएंगे. दोनों टाइप के क्वेश्चन हो जाएंगे, एमसीक्यू भी न्यूमेरिकल भी. और अगर प्रिपेयर नहीं होगा तो एमसीक्यूज भी नहीं लेंगे. तो अपने खुद के स्कोर्स को एनालाइज करना उसी में जिसमें तुम न्यूमेरिकल नहीं कर पाओगे उसी में तुम्हारे ऑब्जेक्टिव में भी कम ही स्कोर हो रहे होंगे. ये प्रिपरेशन की बात है. हाँ. गुड, वेरी गुड। बट टेम्पटिंग करोगे तो फिर अपन कैसे बोल सकते हैं कि गलत होते हैं कि सही होते हैं? मतलब कोई ट्रेंड नहीं है, इट इज जस्ट जनरली मे बी अभी वो कॉन्फिडेंस बिल्ड नहीं हुआ है कि यार जहाँ पे ऑप्शंस नहीं होते उसको कैसे सॉल्व करना होता है, बट डू ट्राई देम, मतलब चांस लो, चांस लो। गलत होगा ज्यादा, उसमें नेगेटिव मार्क नहीं होते भाई, उसमें नहीं होते, उस पर्टिकुलर टाइप ऑफ क्वेश्चन में नेगेटिव मार्किंग नहीं होते। अगर हाँ वेदांत में नेगेटिव क्यों बात अलग है, जेई में नहीं होते, जेई में नेगेटिव नहीं होते उसमें। हाँ मेडिकल में जेई डज नॉट गिव नेगेटिव मार्किंग, बाकी एमसीक्यू 20 क्वेश्चन नेगेटिव मार्किंग, वेदांत में नहीं होते, मनीष तो बोल रहा है। हाँ वो किसी में भी ट्रेंड कभी भी वो चेंज कर सकते हैं, दे आर मेकिंग यू प्रिपेयर फॉर ऑल द पॉसिबल पॉसिबिलिटीज, कभी क्या मालूम तुम्हारे टाइम पे जेई में वापस आ जाए नेगेटिव, यू डोंट नो। छोड़ दो जेई प्रिपरेशन। अरे बिल्कुल, जब कोई चीज करने का मन नहीं है तो फिर उसके पीछे अपन मेहनत कैसे करें? सिंपल है, अगर मेरे को क्रिकेट खेलना पसंद है और कोई मुझे बोलेगा फुटबॉल खेलो तो मेरा मन ही नहीं करेगा, तो मैं क्यों खेलूं? नहीं, क्यों जाना यार, जाके क्या मिलेगा? वहां जाके फिर लगेगा कि यार क्यों की इतनी मेहनत यहाँ चले आए, यहाँ पे कुछ भी लाइफ नहीं है, ये वाली लाइफ। See, it is always like that. See, people who do not like to cook, they don't like to go to kitchen. But people who like to cook, they enjoy kitchen like anything. They don't see कि ये कितना गर्म है, कितनी यहाँ पे फैन नहीं चल रहा है, एसी नहीं है. It's all perspective. It's all what you want from life. Think again, again. My question always, answer is always same. Why do you want to do it? If you really, एक फेज हो सकता है ये, फिर मुझे ऐसा लगता है एक फेज भी हो सकता है ये। कभी कभी फेज आते हैं जहाँ पे महीने महीने पता लगता है क्यों कर रहे हैं, नहीं करना है, टाइम पास है, तो ये टाइम वेस्ट है ज्यादा। बाकी लोग तो एंजॉय कर रहे हैं, मेरे बाकी के फ्रेंड्स जिन्होंने कॉमर्स लिया है उनकी लाइफ मस्त चल रही है, आर्ट्स वालों की तो और भी ज्यादा अच्छी चल रही है, मैं क्यों अपनी जिंदगी जो है स्ट्रेसफुल बना के बैठा हूँ, तो ये वाला फेज आता है कभी कभी, बट इट गोज ऑल्सो। ये बेसिकली वो वाली प्रिपरेशन है जिसमें कभी कभी डाउनहिल भी होंगे, कभी कभी अपहिल भी आएगा। अपहिल में मुश्किल होगी, डाउनहिल में मजा आएगा। हैंग इन देयर, इफ यू थिंक दैट तुम्हें जाना है उस कॉलेज में तो हैंग इन देयर, वही वाली बात है। मैंने एक बात मैं बोला था ना कि कभी कभी हम जब जिम ज्वाइन किया था, मैंने तो बताया था कि बहुत मन नहीं करता था जिम जाने का, पर फिर भी आई हैड टू कैरी ऑन। जिस दिन मन नहीं भी करता था, बस कुछ तो फोर्स लेके चला ही जाता था, और जाने के बाद मुझे लगता था कि अच्छा किया गया। जिस दिन नहीं जाता था उस दिन लगता था बुरा, उस दिन रिग्रेट होता था कि यार क्या टाइम वेस्ट हो गया, फालतू चले जाता, अच्छा रहता है ना। इसलिए हैंग इन देयर, दैट्स ऑल आई कैन से। कूल, ऑल गुड यार, एकदम बढ़िया है ना। ओके, चलो ठीक है, बाय बाय, गुड नाइट। गुड नाइट सर, इज इट ओके इफ आई यूज वन आवर एज माय रिफ्रेशमेंट टाइम? यस, एब्सोल्युटली ओके। Sir, if a body falls and splits into two masses and moves in different direction, then we can solve a whole zip of perfectly inelastic kite. Hridaya? Yes, you're audible. And I'm just giving it a thought what you said. Not exactly. Not exactly, Hridaya. Why? Because in the case of inelastic collision, if you will say that two bodies are coming, they're sticking, then they're going back, then according to inelastic collision, the kinetic energy should decrease. But according to this approach, two bodies after collision breaking down will definitely have lesser kinetic energy because of as in because of not a perfectly elastic collision. So here it will appear as if two bodies were coming, they combined together, and then they started having more kinetic energy, which will be a violation of the overall definition of inelastic collision. Got my thought? That's why. H wala? Yes, 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 yes. Yes, yes, yes. Just a second, I'll show you. Yeah, this one, right? Can you see the slide? अरे she's gone only. Hridaya, you're gone. Okay, Vihan, bye. सर वो नेगेटिव मार्क्स वाले कॉन्सेप्ट मेरे से क्वेश्चन बन रहे हैं तो क्या मैं वो यूज कर सकता हूँ? नहीं नहीं नहीं, पाप लगेगा, मत करो, मत करवा देते रहना, पाप लगेगा। सर, I'm not able to make time for solving that, can you guide a little with my timetable? Wait a second, Sadik. Hridaya, are you back? कर लो यार, मैथमेटिक्स कभी मना नहीं करती कुछ भी करने के लिए। आई नो इरफान, बट जिसके डाउट ले रहा था अभी वो क्लास से गायब, तो वही सोच रहा हूँ कि डाउट लिया जाए। और किसी का डाउट है कोई? नहीं तो मैं इरफान को अनम्यूट करूँ। सर, ए लीनियर मोमेंटम जीरो, काइनेटिक एनर्जी जीरो, व्हाट इम्प्लाइज व्हाट? सर, आई डिडंट अंडरस्टैंड दिस कांसेप्ट, व्हाट इम्प्लाइज? अगर मोमेंटम भी जीरो है, काइनेटिक एनर्जी भी जीरो है, तो बॉडी इज एट रेस्ट। निहाल तापसी, देन द बॉडी इज एट रेस्ट, बॉडी इज एट रेस्ट, नो मोमेंटम, काइनेटिक एनर्जी। System of particles. So for system of particles, the linear momentum is zero, and B is kinetic energy zero. So assertion reason is it? B implies. एक minute, linear momentum is zero of the system, not necessarily kinetic energy zero. But if kinetic energy is zero already of the system, then momentum is zero. B implies A. A does not necessarily imply. Say if there is a body which is at rest, it explodes into two pieces. The momentum remains zero. System ka momentum remains zero. But both the bodies have now kinetic energy, so overall system has kinetic energy. That's why. Bodies are not moving. Why would they have momentum? Because kinetic energy is a scalar quantity. Momentum is a vector quantity. That's why. Energy is a scalar quantity. No, momentum is a vector. इरफान आ जाओ। यस इरफान, टेल मी। कितने बजे से? 8 से 12:40। ठीक है, ठीक है। फिर 5:30 से क्लास हो जाती होगी। ओके, एंड 2 to 7 आई गेस, 7 o'clock you wake up. अच्छा, क्लासेस आर हैपनिंग एट स्कूल, का क्लासेस आल्सो हैपनिंग इन ऑनलाइन ओनली, राइट? बता, ये 5:30 to 7:30 हर रोज होता है? ठीक है, तो बेसिकली यू विल हैव टू मेक टाइम फ्रॉम दिस 5:30 to 7:30 वाला स्लॉट। तो जिस दिन नहीं होता है ना, उस दिन यू विल हैव टू स्पेयर टाइम फॉर योर तत्व सॉल्विंग फॉर द। आई नो, आई नो, आई नो, difficult time. What I suggest you figure out, I would generally recommend to solve Tattva at the night when the efficiency is very less. Numerical problem solving should be done when you are, means I generally consider problem solving to be a fun activity. It is starting from there. So if you consider something more fun, you should try to do it when you are not very active. At that time, especially whenever you are not very active, you should try that. So try to figure out the time slots, how much, what you should be studying and how you should be studying is very important. Like for physics, I can say, should not be going through theory again and again many times. You should rather just have your class notes from my class, take the notes, take important formulas, keep a mental note of things, and then just get to the problem solving directly straight away. Okay, keep the notes open, these PDFs, keep them open, start solving the questions directly straight away. Physics mein your approach of revising should be tattva solving. Like I'm guessing that you will be studying after the class tonight also. So my recommendation, whichever is the class that has happened that day, you should actually in the night do the tattva the same day, especially if it is maths and physics. Sunday exclude kar do, I'm actually considering Sunday doesn't exist. Sundays are always reserved for your unit test, your Vedantu test, or some backlog to cover. I do not ever in my life. But you should actually exclude Sunday from whatever timetable you make so that you can actually cover up for the week whatever you did not do on that week. On that Sunday, you can do that. When you are solving Tattva for the first time, I have told you that when you are solving anything, when you are studying anything, you should always have a marking of importance level, means 3 star, 2 star, or 1 star. For the test, when you are starting to study, by that time you should already have done a round of Tattva solving of that chapter or those chapters. So if you still have good amount of time and I've told you how to approach Tattva, don't solve each and every question of Tattva in the first board. 100 questions, so first, then fourth, then eighth, then 12th, like that. So in the second time, when you are now revising for the test, if you don't have much time, just go through those questions which you have marked as double star or triple star. Okay, if you have good amount of time, solve questions which you have not tried in the first attempt. But my suggestion once again is always when you revise for a test, to revise from your notes which are star marked, revise from the Tattva questions which are star marked. That's the best way to revise. Okay, and you have to mentally tell yourself that I am not always going to go for a test during this phase with 100% preparation because I'm still in the process of learning. Once my syllabus gets completed, then, or maybe once a major test comes, that is when it is expected that you are at your 100% preparation. Unit tests or bi-weekly tests at Vedantu are the part of the learning process to ensure that whatever you learned in the previous, 2 weeks or 3 weeks, you still have a recapitulation of whatever you studied. Those tests are for that. Remember, the objective. Definitely, it is to keep you in sync with what is happening with your studies. It's that. Okay. Sir, I was solving questions. I came across a question in which there are dotted lines starting from the origin. Then it is regular. What does that mean? Hai? Totally your call, Nihal. I have no comments on that. I have no comments on that. Both have pros and cons. Hannah, I'm not able to understand what does it mean. It is a graph between energy and momentum. It is a graph between energy and momentum like this. Energy on y, momentum on p, momentum on x, and the graph is like this, like this. Now, parabolic graph must have been. It must have been a parabolic graph. Must not have been a straight line graph, है ना? हाँ, but मतलब parabolic भी था ना? तो हमें मालूम है ना ये एनर्जी काइनेटिक एनर्जी है क्या? ये काइनेटिक एनर्जी है क्या? तो हमें मालूम है कि काइनेटिक एनर्जी जो है वो p²/2m होती है. मतलब अगर ये y है और ये x है तो y प्रोपोर्शनल टू x² टाइप ऑफ ग्राफ बनेगा. मतलब x की वैल्यू नेगेटिव पॉजिटिव y पॉजिटिव आएगा. ये ग्राफ बनेगा. ये ग्राफ है. दिस इज द आंसर. अब वो डॉटेड है नहीं है उससे फर्क नहीं पड़ता. बट ग्राफ ये है. E वर्सेस p² ग्राफ है. ग्राफ E वर्सेस p² है. तो E वर्सेस p² विल बी अ स्ट्रेट लाइन लाइक दिस. बिकॉज़ p² अगर x हो गया तो अब y प्रोपोर्शनल टू x हो गया ग्राफ. देन द ग्राफ विल बी दिस. ठीक है? Nothing significant in this graph. Dotted lines का कोई significance इस ग्राफ में तो नहीं है. Okay? ठीक है guys, shall we call it a day? मिलते हैं वापस Wednesday को. Okay, चलो guys. Yes, bye bye. Good night everyone. See you all in the next class. Good night. Hasta la vista. Yes, bye bye. Sayonara.